Hello, ladies and gentlemen. I hope you're all doing well, and I want to thank you for joining me. We're going to be starting another of the University of Waterloo's excellent math contests. This time it'll be the Grade 10 Galois paper from the year 2018. So this is, as I say, a Grade 10 level contest. It largely requires written solutions, as opposed to the Cayley contest, which is their Grade 10 paper that just requires multiple choice answers. So we're going to have to be writing things a bit more clearly if we want all the marks. And yeah, so it's the 2018 paper, as I say. If you want a copy for yourself, you can download a copy by clicking the link down in the description below. I always try and encourage you guys to print them out and practice them, with a friend. You can feel free to race each other, but just to see how far you can go and to really identify your areas of strength and your areas of weakness. So these are things that you can focus on when you're preparing for perhaps the upcoming Galois, or really any upcoming math papers. Okay? So let's have a look-see, shall we? So, as I say, grade 10 paper, it's the Galois, and it's the 2018 paper. I'll let you read the instructions here. If you're writing an upcoming contest, it's always a good idea to understand the instructions. Are calculators allowed? What are time limits? These are important things. So, there's the time limit. That tells me about calculators. That tells me the number of questions. And the mark breakdown. If we're trying to maximize our score and do well, we do want to be keeping an eye on the marks. And yeah, so, I've gone through a few Galois. I don't always read out the instructions. I will let you finish reading these out if you want to. Download a copy of the contest or just pause the video here. But we're going to go right into the first question and then the second question in the next video and so on. So, question number 1 here I can see has 4 parts. There are 3 light bulb parts, which just require the final answer, and then a written style question where we do have to justify everything, explain what we're talking about, ideally using complete sentences, that sort of a thing. But what have we got for 1a? Given that x isn't equal to 0, simplify the expression 12x squared over 3x. Okay, they just need the final answer, but we can show our work for part marks in case we do screw up. A light bulb question, usually worth 2, maybe 3 marks. So there's not a whole lot in terms of part marks to be had, but 3 and 12 cancel out and leave a 4 on top. And if we want to break this down into very many steps, 4x squared divided by an x, so 1x will cancel out with the square on top, and we're just going to be left with 4x. We don't know what x is, we just know it's not 0, so the division can take place. So our final answer is just going to be 4x. And that's what we would write down for 1a. Alright, 1b. What is the value of the expression 12x squared over 3x when x is equal to 5? Okay. Now we could plug 5 into this expression in both places that we see an x and simplify from there. Of course, we can always grab our calculator if we need to. But in a, we already simplified this expression. So we might say something like, by a, 12x squared over 3x is equal to 4x, and plugging in x equals 5, we get, 4 times 5 is 20. That way I don't have to do 12 times 5 squared over 3 times 5, where I would probably need to reach for my calculator at that point. Simplifying using part A allows me to answer the question quite quickly. Okay, so now C part. Given that n is equal to 2 times m, and that m isn't 0, and that would mean that n is also not equal to 0, what is the value of the expression 8mn over 3m squared? Okay, well, let's write down our expression. Okay. Now, I notice I've got an n. I know a little something about n. It's equal to 2 times m. So bringing the 2 and the 8 together, we get 16. Bringing the 2 m's together, we get m squared. And since m isn't 0, m squared isn't 0, so we can actually cancel these 2 out. And we're left with 16 over 3. I would leave it like that rather than writing something like 5.33333 or 5 1/3. But if you want to, those are also going to be acceptable answers. But we try and keep things as exact as possible. Okay, especially for later questions where exactness is going to be quite important in some cases. Alright. So there we go. And now D part. This is the one where you have to be a little careful, explain anything that we are doing that isn't obvious. And so what have we got? D. If Q is equal to 6, determine all positive integers P, for which 3 is less than or equal to 8P squared Q divided by 5P Q squared. And that also has to be less than or equal to 4. So the first thing I'm going to do, and I'm actually going to write this down. We already know that Q is 6, so really why don't we just plug this into the expression? They're making this expression in the middle seem scarier by having multiple variables, but really we could simplify this and use our Q equals 6. So we have 8, I think it's P squared Q, I'll check in a moment, and then I think it was 3P Q squared on the bottom. Right, P squared Q and then PQ squared. But it's a 5. It's a 5. Alright, so what could we do? Well, this P and this P will cancel out, and the Q on top and one of the Q's on bottom will cancel out. So we'll have an 8P on top over 5Q. But of course, we know that Q is 6. So we get 5 times 6, 8P over 30. We could divide a 2 on top and bottom and get 4P over 15. So that's our middle expression. Okay? So we want 3 to be less than or equal to 4P over 15 to be less than or equal to 4. It is less than or equal to, right? Yes. And we want positive integers P that satisfy this expression. Okay. So, suppose we could multiply by 15. And you could write that down if you want to. I would say as long as you line it up clearly like this, everyone's going to know you're multiplying by 15. So if P is a positive integer, 4P is a multiple of 4. So by our inequality, (45) less than or equal to 4P less than or equal to 60, we can get a list. 4P has to be a multiple of 4 between 45 and 60. Well, 60 is a multiple of 4. 45 isn't. The next one after 45 is 48. And then counting up by 4 is 52, 56, and 60. This gives P is, well, just divide by 4. P could be 12, 13, 14, and 15. And that's all possible values of P. They wanted the values, right? Yeah. Sometimes they ask how many values, but this time they actually wanted us to determine all values of P. And one thing you can do, just as a quick little double check at the end, is you can grab your calculator and pick a random value of P and test it. You could also pick a random value of P that's kind of close, like, say, 11, and see, does that also work? So we might say something like 8 times 11 squared times 6 divided by 5 times 11 times 6 squared, which is 36. And, oh, that's 2.933. That's a little too low, but if I did something like 13, 8 times 13 squared times 6 divided by 5 times 13 divided by 36, that's 3.466. So that one does work. And we could check all of them, but as long as you're confident in your math and your understanding of the way you made your inequality, that's fine. And we showed all our work. We showed our lists of numbers. We're all set to go. All right. So that's question number 1. Hopefully we've gotten ourselves a good 10 out of 10, which is a great start to the contest. Up next, we're going to be going through question number 2. So feel free to skip over to that video. Or if you're looking for something specific, maybe you actually tried the contest and you got everything, you just couldn't quite get question number 3, jump ahead to question number 3. That's fine. I will see you there for whatever math video you watch next. Okay? Have a good day.